Yeah, that looks. Real estate ads suggest that 64% of homes for sale have garages, 21% have swimming pools, and 17% have both features. What is the probability that A pool has both a pool or a garage? To figure this out, the first thing you're going to need to do, if Campbell hasn't already told you, is draw a picture. As silly as this may seem, it definitely helps you out. From what you've been told in the problem, you know that 17% of homes have both a garage and a swimming pool. What this means now is that you don't write 21% for your swimming pools. Rather, you write what's left over, in this case 0.04. On the left side, where you were first told that you have garages in the homes, you don't write 64%, but 64 minus 17, or 0.47. This now helps you see what your actual values will be for your percentages. To find the probability of a house having a pool or a garage, you can set it up with the probability of A being a garage or a pool, signified with B. This equals your raw value for the garage plus your raw value for the pools minus your actual intersection, which is both, or in this case 0.17. Adding these together and then taking away the intersection gives you a total value of 0.68 for the probability of a house having either a pool or a garage. Part B asks, what is the probability that a home for sale has neither a pool nor a garage? In this case, you can signify it as the probability of a house having neither feature. To find this, all you do is 1 being 100% of homes minus the probability that you found of a house having a pool or a garage. So all you do is 1 minus probability of A or B, which you found from part A, to give you 0.32%, or 0.32, or 32%. Part C asks, what is the probability that a home for sale has a pool but no garage? In this case, all you're looking for is the probability of a house having a pool. Looking at your Venn diagram, you realize that you don't have 21% as given in the original raw. Rather, the probability of having a pool but no garage, which is only this section here, is 0.04, or 4%. On to the next problem. Number 3. A check of dorm rooms on a large college campus revealed that 38% of them had refrigerators, 52% had TVs, and 21% had both a TV and a refrigerator. What's the probability that a randomly selected dorm room has part A, a TV but no refrigerator? Again, you're going to want to draw a picture. On the left here, you can label it as dorm rooms with fridges. On the right, dorm rooms with televisions. You were told in the problem that 21% of dorms have both features, meaning that on the left, dorms with only a fridge will end up having, dorms with only a fridge make up 17% of all dorms, while dormitories with only televisions make up 31% of the remaining dorms. Now, to solve part A, look at a TV but no refrigerator. You can write this as the probability of a TV. Looking at your Venn diagram, you can see that the probability of only having a TV is 0.31. Part B asks, what is the probability that a randomly selected dorm room has a TV or a refrigerator, but not both? This can be set up as probability of A or B, which you then just put in your raw values of 0.17, or sorry, 0.38 plus 0.52 and subtract your intersection of 0.21. This leaves you with a final value of 0.48. Part C asks, what is the probability that a randomly selected dorm room has neither a TV nor a refrigerator? In this case, you can write it as probability of neither amenity, which would just be the probability 1 minus the probability of A or B, which brings you to a final value of 0.31. Excuse me, I'm thinking of the wrong math. What you do in this case is you add up your values of 0.17 plus 0.21 plus 0.31 and then subtract that from the total. 1 minus 0.69, giving you a final value of 0.31. On to the next problem. Question 6 reads, a survey of students in a large introductory statistics class were asked about their birth order, category 1 being oldest or only child, and which college of the university they were enrolled in. The results are listed in the table in your textbook. Suppose we select a student at random from this class. What is the probability that the student is A, a human ecology student? In this case, you get 43 out of 223 total students, giving you a value of 0.142. Part B asks, what is the probability that the student is a firstborn? In this case, you will write down 113 over 223 for your total students, giving you a total value of 0.501. Part C, what is the probability that a person is both a firstborn and a human ecology student? In this case, you would write the probability of A and B, because we are looking for both, equals the probability of A times the probability of B given A. The probability of A was given to you from Part B, so simply write down 0.501 times .132 7 with a value of 0.067 as your final answer. Part D asks you, what is the probability that a person is firstborn or a human ecology student? In this case, you get probability of A, which you've learned from Part B, is 0.501, plus the probability of a human ecology student of 0.142 minus the probability of both, or what you learned from part C being 0.067, giving you a final value of 0.576. On to the next problem.